Hello, everyone. Good morning. Is it audible? Cool. Let me start with asking a question to everyone. How many of us think that sustainability is important, not just in our daily life, but in coding practices as well? Oh, it's I expected that. Whoever is here would be interested, and all of us are. Thanks for that. So, let's set some key expectations from the session. So, together with you, I'd like to answer a few questions while we go through the whole presentation. The questions here are why we need efficiency and optimization, how we want to do, what we want to use for it, when we need to think about sustainability altogether, and who, who need to do it. This is $1 million question. Let me dive into a few statistics that actually bothers me, and I hope it bothers you as well to make a change. So, uh, as of now, ICT has around 1% to 4% of total emission contribution in global greenhouse gas emission. So taking around midway somewhere, it's around 1.8%. When I take that, it's already around 653 billion tons of greenhouse gas emission, which is equivalent to 163.35 or around 160 million peoples per year emitting the greenhouse gas per year. And you can see some of the statistic over here, which says that even it's equivalent to 1.6 million private jets, considering it runs for 200 hours each year. And there are around only 22,000 private jets right now. So it's a huge number, and it actually bothers me. Looking at more statistics, uh, uh, on total ICT, data centers have around 45% of contribution where we lie. We also are on desktops or others, but mostly around data center where our code runs. Looking at the trend pre-pandemic, it was already increasing, and post-pandemic, it has skyrocketed. Let's understand sustainability in Python development through a walkthrough that I would like to present today. We'll see what are the environmental impacts in development we make. How can we measure the emission? I have an example, a training model that I would like to go through whole optimization phase. How can we do resource optimization? There are many ways, but some of them which can make us more sustainable, and how energy efficient algorithm help us in doing all these stuff. Looking at environmental impact of Python development. So there are two ways I can do right now due to a rise of LLMs. I see that comparing it with other languages and comparing different language models that we have currently. When we compare it with other languages, the energy consumption is really bad, means really huge for Python, and the time it takes for execution is also not really nice. Looking at some of very sustainable languages. So I then move towards the language models that we have and see how it's going on over there. So as new language models are coming into picture, every new language model requires more energy, and the emission is increasing day by day. So it's up to the not recent, but GPT-3, you can see already the most popular one, how much does it consume per year. So we know why, I think, more or less, why we need to be more efficient and optimize looking at these data. Let me dive more into how we want to monitor the emission altogether. There are a couple of tools, more than a couple of tools, but more prominent are Code Carbon and Carbon trackers. I have used more of Code Carbon, so I will use in my presentation more Code Carbon, but Carbon tracker as well is good for machine learning kind of code. So And Code Carbon is good for in general for any code where we can track our emissions. So what does Code Carbon, how does it work? So Code Carbon works with, it's an open source tool. It actually take in account about your hardware, which hardware you are running and which location you are in, and it calculates on the basis of the hardware how much energy is being consumed, and on the basis of the location you are, if the renewable energy is used or the energy is much greener, it shows the carbon emission. So can be that at some places when you run, it shows zero emission altogether. The dashboard has a lot of content. It even shows comparing with different other well-known emitting objects like cars, TVs. Okay, sorry. Yeah, shall I repeat or should we fine?
No, you can continue.
Okay, cool. Let's look into setting up the Code Carbon. So setting up Code Carbon is pretty easy. We can just do pip install Code Carbon, and then just import it, initiate the tracker, and start the tracker whenever the code execution start and stop it. So for ease, we can also print the emission in itself, how much emission we have done, but it comes up with a CSV file, which is actually used by the inbuilt dashboard that comes with Code Carbon using DAS. It is built using DAS, the Plotly one. So here is an example training model which I'll be working going forward to see how we can optimize, what will optimize this code going forward. So this is a simple training model which use MNIST dataset. It actually trains the model and then evaluates on the accuracy or the loss that comes out of it in 10 epochs. So it's pretty fast compared to many data models, and a very simple one. When I just ran it with the code that I showed you right now, the Code Carbon showed me a dashboard which shows that I already emitted around 2.1 kg of carbon dioxide into the environment, considering 10,000 iteration, because it's in one iteration it's very less to show. The dashboard shows in at least kilograms, so I had to make it to 10,000 iteration. And we can here see the net power consumption is 5.8 kilowatt hours. And due to some contribution in renewable energy in Netherlands, the location I kept in the Netherlands, the emission is less, but it's much higher at the places where there is no renewable energy being used. Yeah, and we can, so as we run this, we can select different projects because there is a filter for different projects. So we can keep on working and the filter will work upon. First step that I tried to, in order to reduce the emission of my code, I tried to do resource optimization. And as we already heard few things about profilers, but I'd like to briefly go on the things that I have used. I used some static code analysis tool like PyLint. PyLint is well known to every one of us. It actually gave me an idea about some of the unused part in my code. Radon actually helps us to find if there are any cyclomatic complexities in the code, which can eventually lead to much runtime. And then some profiling tool like cprofile, line profiler. I actually use visualizing tool for the profile data via SnakeVis to have more data, but I even run snake run, or you can just go through the data and visualize if you like. After optimizing through the output of these tools, I was able to already reduce 200 grams of carbon dioxide emission. If you could see, it's now 1.9 kgs already. So those were very basic optimization. The cprofiler data helped me to further look into what more can be offloaded or optimized, but with very basic optimization, it was 10% of gain. Looking in bigger picture, it can be much more. So here you see that I have saved 1 hour of dB2 watts for me, from 21 hours to 20 hours. So this is how the data looks for one iteration. 200 it was just evolved 200 micrograms for the raw code that I presented earlier, and later it's just below 200, which is around 10% of gain. Further, in order to optimize it, I thought to use design patterns because we never know what it's gonna bring. I thought it's gonna do nothing at all because it's just structuring the code into different structures, and what's just design pattern is gonna do. So I tried different types of design pattern categorically in different sectors like structural, behavior, and creationals to see what it brings to my code. After using design patterns, the output has changed a lot. So I see here that the original code is around 200 micrograms, and with using different kind of design pattern, the emission has been reduced. Mostly by observer design pattern. Maybe it's due to my code structure, it was useful over there, but it may not be, so it's always good to find design pattern that suits you better. Yep. In my quest, I further looked into energy efficient algorithms. So my code was really simple, but there can be something that could be used to make it more energy efficient. I used the raw code. I didn't use the already optimized code. I used the raw code. I removed some of the layers, and I also used the libraries which are more up to date and more sustainable. So after applying the energy efficient algorithm, the gain was again around 25 to 30%, little just above the observer pattern, but around 25% is. Further in my quest, I was thinking of what can I do to reduce the overall sustainability index of my code. So very interesting language called Rust, which is very new, but it came into my mind. And there is an interesting library called PyO3, which has been discussed all over the internet, but I thought, what if I use that? But I was already using TensorFlow, but TensorFlow is highly optimized in itself. So what can I do? But still, I tried to download the whole MNIST dataset. I further tried to offload the data loading part and data processing part to Rust, and use one of the structural design pattern to reduce more redundant code. And after just using PyO3, I was able to reduce the code again to 25%, along with a design pattern which I like more, called facade. But it's the gain from Rust, using Rust, was very imminent, means it was around 25%. It was similar to what we saw with observer design pattern and energy efficient algorithms. Further, I thought I need to test one more time what happens if I use compiled code. It may not do anything because already everything that's been trained is on the machine level, so I don't think it will do anything. But when I tried to compile the code, both normal code that I have and then the Rust version of the code, the remaining part of the Python, the gain was around much larger than what I gained from all of the previous iterations. So it was again 25%, and it's all on the raw code. I didn't do optimize one by one. But looking at the whole picture, there are multiple methods that we can apply to our code altogether to make it more efficient. A design pattern that suits us better, and energy efficient algorithms, or using Rust to offload few parts, or even using compiled code. There can be several ways. By applying this, I was already able to reduce 25%, around 25% of carbon emission, or making it 25% more energy efficient to say, which can save me hours of TV to watch from the dashboard we saw earlier. So this was a quick introduction on how we can use design patterns. We can maybe discuss later on what changed on using different design patterns and how we use PyO3 afterwards. Let's move into an interesting topic called the benchmarking. So how we benchmark our sustainability in general. So in general, sustainability is benchmarked on the basis of few factors. The factors such as carbon footprint, energy consumption, waste reduction, water uses, and supply chain sustainability. For us, more of interest are carbon footprint and energy consumption, because other parts are mostly on the data center side, or mostly not useful for us, or we don't have enough data to support it. So in order to benchmark where we stand or what we need to do to become more sustainable, there are a few things to consider that would help us to benchmark on how much we can reduce or where we stand right now. So one of a very interesting thing is industry average energy use. We may not everyone be in ICT, but we can be in finance or any other industry. So we need to know what's our industry average. Then we can see the energy star ratings of different components involved in the Python development, including the devices to data centers, the LEED certification standards that stands over there for different components, and what's the percentile ranking within industry. So what's the coding part in our industry itself. With this benchmarking, there is a very interesting key performance indicator called ISO 14040. Well, it's in general standard that talks about life cycle handling, so life cycle assessment, I would say. But it's a very interesting framework which can also be related to software development or in general with Python projects. So how we can implement in Python projects, there are a few points that we can consider while doing it. Is we can access and optimize energy efficiency of the code, as we talked already. Choosing hosting in data centers powered by renewable energy. Selecting libraries and frameworks designed with sustainability in mind. So these are the few takeaways that we can see from ISO 14040. Talking about example, most of the industry in ICT try to incline toward 14040 series. So there is another standard in this series which talks about what actually needs to be done towards solving this issue. Looking at all the assessment that we did, means we tried to reduce the emission from our code, benchmark the code. There are few things that can be considered as best practices for sustainable Python development. From many, I can come to few. So one of the interesting one is established code review guidelines. As we do for our coding standards, we can have a code review guidelines which actually considers sustainability. We can integrate different sustainability checks in CI/CD pipelines that we use to deploy our code from dev test and prod, or in general. So what can we have? How can we have sustainability in mind while doing code review? So there are a few things that we can always consider. We can consider what's the cyclomatic complexity of the code. What are the execution time and bottleneck? So the output of it, to see if it can be more optimized. Redundant code elimination, efficient design pattern. So every project has its own design pattern consideration. One may not fit all. Code carbon visualization to see how optimize the code is being, and resource optimization tools. So using different tools to optimize it. This is a sample pipeline. Actually, I'm a AWS engineer as well, so I use code pipeline a lot. So I can share you a sample pipeline that I use. So here you can see different blocks that are related to the checks. One is static code analysis, which we saw with PyLint and Radon. So this outputs the result of that. Then unit test as usual. Then the profiler, and the last one is code smell. Although static code analysis and profiler gives us idea of what are the code smells in the code. But here I use Gen AI actually to help me support the hidden facts. I may not have seen everything. It may not be right every time, but I ask it to read my code and find any code smells that it can find, so that it's more visible to the reviewer that what he or she is going to look at. So, not a conclusion yet, but let's see if we have our key takeaways in track or not. So we discussed about why we want to do it with all the statistic, how we want to visualize it, what we need to do it, the different techniques we saw, and when we need to do it. So during code reviews, during CI/CD pipelines. Now the most important part is who needs to do it. So this is as usual some data from internet. So but it shows that by 2021 itself there were around 10 million Python users from Developer Nation survey, which is used. Looking at few other indexes like PyPL and TOB, as we discussed this morning as well, Python is the most popular language, and its popularity is growing day by day. It's one of the most easy language to learn as well. So let's discuss. It's clear to us now who needs to do it. Me, you, us together. We need to act upon it. So what can we do as part of our job? So there are certain things we can always practice to be more sustainable. We can engage in discussion about sustainability with peers, with reviewers, with managers, with stakeholders as well. We can emphasize the sustainability during the design phase of application. We can focus sustainability throughout the development process. We can introduce certain checks in CI/CD pipeline. We can conduct peer review with focus on sustainability practice. We can make decisions with sustainability in mind. So every line we write, we can just think of, is this more sustainable than the other alternative? So before I conclude, I'd like to say it's a privilege to be here talking about something that both drives and concerns us all, sustainability in our profession. But as I delve into the complexity of sustainable Python coding, let me share a little story from my homeland, Nepal. Imagine waking up to the serene views of Himalayas, these majestic giants, not only towering symbols of natural beauty, but also, sadly, of vulnerability. The melting Himalayan glaciers, a reminder of our warming planet, led me on the path I stand here together to think about sustainability. So let's, each line of code I write, I actually think of them. So I think of them every time I write the code. It's not just about programming, it's about actually preserving. So thank you.